Carl Sagan famously said, and it's one of my favorite quotes of all time, extraordinary claims require extraordinary evidence. So, what evidence do we have for an ancient planet? What is the current scientific estimate for the age of our beloved planet Earth, the third rock from the sun? Recall that uranium 238 is going to eventually decay into lead 206 in a stepwise radioactive decay chain that has a very, very long half-life. So it's going to take almost 4.5 billion years for 50% of the uranium 238 in a rock sample to decay to lead 206. So the oldest rocks yet discovered on planet Earth are these tiny little zircon crystals that are embedded throughout the mountains. They're called the Jack Hills in Western Australia. Western Australia is going to end up being really important to our story. Because of plate tectonics, it just happens to have some extremely old rocks at its surface. It's also where we're going to find the oldest evidence of biological life in Shark Bay, but we're coming back to that. Anyways, analyzing single atoms of lead, researchers have confirmed that this crystal is the oldest rock fragment ever found on planet Earth, dating at 4.404 billion years old, plus or minus 8 million years. What an awesome discovery. Over 50 years ago now, on July 16th, 1969, at 7 p.m. Eastern Standard Time, Apollo 11 astronauts Neil Armstrong and Buzz Aldrin landed their lunar module with only 30 seconds of fuel remaining on planet Earth's moon. Armstrong radios, quote, "Houston, Tranquility Base here. The Eagle has landed." At 10:56 p.m., Armstrong is ready to plant the first human foot on another world. With more than 500 million people watching on television, which was an astounding amount at that time, he climbs down the ladder and he proclaims, quote, "That's one small step for a man, one giant leap for mankind." Aldrin is going to join him shortly thereafter, and he offers a simple yet powerful description of the lunar surface. It's magnificent desolation. They explore the surface of the moon for 2.5 hours, and they collect 21.5 kilograms of rock. So that's over 40 pounds of moon rock. They leave behind an American flag, a patch honoring the fallen Apollo 1 crew, and a plaque on one of the Eagle's legs, and it reads, "Here, men from planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all of mankind." So, those samples of moon rock, again, using uranium to lead radiometric techniques, dated at 4.44 and 4.51 billion years old. Why? So the giant impact hypothesis, sometimes called the Big Splash, indicates that there was once a Mars-sized planetesimal called Theia that collides with the proto-Earth and ejects all of this material, which forms this large debris ring around planet Earth. That debris, because of gravitational forces, eventually condenses to form our moon. This collision with Theia also resulted in the Earth's tilt of 20 3.5 degrees, which we know causes the seasons. But the important point is the moon's oxygen isotopic ratios, signatures in the rock, seem to be essentially identical to planet Earth's. So planet Earth and the moon are essentially made from the same stuff. And the moon rocks dated at 4.5 billion years old. Hey, did you know that the world's best preserved meteorite impact site on all of planet Earth is just 37 miles outside of Flagstaff? So it used to be called Barringer Crater. It's been renamed to Meteor Crater. It is the spectacular result of a collision that rocked the American Southwest approximately only 50,000 years ago, with the energy of more than 20 million tons of TNT. So the remnants of the Canyon Diablo meteorite date between 4.53 and 4.58 billion years old, giving us yet another age estimate for the formation of our solar system. So here's Flag right here. So if you just take the I-40 east, and then you can see the little road running south. So it is a giant hole in the ground, which is evident from satellite imagery from Google Maps. So given these three lines of evidence, all based on uranium to lead radiometric decay, dating first tiny zircon crystals in Western Australia, as well as gneiss, that's gneiss with a G, rocks from northwestern Canada, which date almost as old. Second, samples of moon rock collected and brought back. And then finally, recovered fragments from the Diablo meteorite. All of this suggests that the best scientific estimate that we currently have for planet Earth is 4.54 billion years old. That's billion with a B, not millions. Plus or minus 50 million years. So what's up with the plus or minus 50 million years? So this is an important point. The plus or minus is called the standard error. And you're going to see it. Anytime you see a scientific estimate, you'll see it followed by plus minus symbol and then the standard error or the SE. Remember that in science, it's a different thought process. In science, we are going to attempt to systematically quantify our uncertainty. And we're going to do this with repeated measurements. So we don't just measure things one time in science. We're going to measure things repeatedly, and inevitably we're going to get variation in those measurements. But what I do need you to know is the standard error is a measure of our precision. Okay, how confident we are in our estimates. So if you see a standard error that's large relative to the estimate, then you know that the measurements were kind of all over the place. They were imprecise. However, if the standard error is small relative to the magnitude of the estimate, then we know that's a fairly precise estimate. And so given that we're talking about 4.5 billion years, plus or minus 50 million years is a relatively precise estimate for something so old. Okay, so this is the way that accuracy and precision is usually explained, and you're going to see this on your assessment. So make sure that you've got it. So again, precision comes from repeatedly measuring things, and something that has high precision means that those measurements are all quite similar. So if we think about a dartboard, this is a highly precise dart thrower. All of those darts, those estimates are clustered together. And then this is highly precise. Accuracy also has a very clear meaning in science. Whereas precision is a measurement of the repeatability of our estimates, accuracy is how close are our estimates to actual truth. So here we have relatively low precision. We're kind of all over the place, but we're in that bullseye area. So assuming that the bullseye is truth, this is a relatively accurate dart thrower. This dart thrower has low precision and low accuracy. Not only are we all over the place, but most of our darts are ways away from truth. This, again, high precision, but low accuracy. We're a ways away from truth. And then finally, we're both hitting truth and we're repeatedly hitting truth. So hopefully that helps.